Well, what I have here is a little bit of troubleshooting on a Sansui AU 7700 power amplifier. I was originally having trouble with this a chattering noise taking place. You would slam on the top of the unit and the chattering noise would go away. It would basically click, latch in, and you'd end up with music. And now it doesn't do this any longer. So doing a little bit of troubleshooting, I was able to figure out that this particular diode here, which sets up DC voltages for the protection circuit, which includes that relay, was faulty. But that was only part of the problem, and eventually the unit stopped working once again. It's been a long time since I could actually get back to working on it again. But what I found was that the service manual was not very helpful in this case. This is the particular circuit we're talking about here. That's the diode I replaced, and it's creating a DC for this circuitry. And basically, if it finds a voltage, a standing voltage on the output, it will trigger one of these relays, whether it's a negative or positive, and it will put this particular transistor here into cutoff, shutting off that relay. But what I'm seeing is some pretty strange behavior. Looking at it with a multimeter, I find 15.9 volts there on that particular transistor, and incoming voltage of 19 volts. Well, I find that strange because this transistor should either be in saturation or cutoff, which means that point there should be nearly zero, or should be 19 volts, which is not the case. And then I find here with a multimeter 0.594 volts, which is inside the operating region of that transistor, most likely. So I'm trying to rack my brain here. Where can I get more voltage for this particular circuit? I originally thought it was the thermistor, but that seems to be working properly. I disconnected it, giving it infinite resistance. That didn't seem to help. So I was trying to figure out where I could get more voltage here, and decided to move to a scope. And when I went to the scope, I found here the same AC. It was an AC writing on a slight DC, as I would find here, which I would imagine would have supposed to have been mostly a DC potential, based on this particular circuit here. D11, D21 over here to that capacitor, which is a 33 microfarad 50 volt capacitor. So just dinking around, I decided to look around for a capacitor that might improve the situation there, because after looking at it on a scope, it didn't seem that capacitor was working. So I put this one in parallel. I didn't have a 33 microfarad and 50 volts, so I only had, most of my capacitors were 25. So this particular one is a 10 microfarad and 50 volts, and I put it in parallel there to hopefully increase the capacitance of that circuit, and maybe actually increase the amount of DC felt by the rest of the circuit there. And this is what I found. I'll turn this on here for you. The yellow trace is the incoming voltage to the circuitry, so that's the after that rectifier. The blue trace is what's actually being felt. Oh boy, battery's dying. Blue trace is right here, and the orange or the purple trace is right there, the bias to that transistor. So let's give it a shot. As you can see, it's still in the operating region there. The blue is what's being felt across the transistor that's supposed to be operating that relay. It's enough to get the relay to actually engage. but you can see the yellow input voltage is still very much an AC, not rectified enough in my opinion. So 10 microfarads not enough. I think that 33 microfarad capacitor is bad altogether, so I'm gonna get a new one of those and see if I can improve the situation. But this is reliable every single time that I've turned it on here. This is it operates properly. So let's see here. That's the capacitor that I put in. So I guess I'll keep you posted as to how the rest of it goes. I think I have a couple power amplifiers to replace as well, but at least now the protection circuit is working properly. So thanks for watching.